Hey everybody! In this video we're going to kind of do an introduction to trigonometry, and more specifically it's going to be right angle triangle trigonometry. So a couple different branches of trigonometry, but this is just going to be starting with just the triangles and kind of how the relationships work with these. So let's say we've got these two triangles here, triangle ABC and triangle DEF. And we can see that they're both right angles. They both have right angles at angle C and angle F. And the measurements of the other angles are the same as well. So even though they're not the same size, we can say that triangle ABC is similar to DEF. And similar just means that it's got the same inner dimensions. The angles are the same. The sides may not be the same, but if we could do a fraction of side AC over BC, and if we compared that to DF over EF, that we would find out that those two values would be the same when we fully simplified. Now the fractions themselves would be different, but when you simplify the fractions all the way down, you would get the same value. Or if you convert it to a decimal or a whole number, those values would be the same. And similarly, we could do the same with AC and AB, and DF and DE. And notice these things are, I'm lining up the matching sides, the corresponding sides here. So AC is that left side of the ABC triangle, and DF is the left side of the DEF triangle. And then, of course, our last combination also works. And this all works because everything is proportional to each other. All of these sides are all proportional to each other. So if you know you've got the angles the same of all of them, then you've got the measurements of the sides are proportional to each other. Okay, so let's look at how we sometimes label these sides, because doing all of these letters like this, the capital letters, can get kind of annoying or maybe a little tedious because there's so much to write in there. So sometimes what we do is we'll label sides based on what's opposite of the angle. So opposite of angle A would be side A. So we usually use the little letters, the lowercase letters for the sides, and the capitals for the angles or the vertices. So opposite of A is going to be little a, opposite of B is going to be little b, opposite of C is going to be little c. And if we take this definition, which you may have heard before or know from before, A and B, we call these things the legs of the right triangle. Right? This is for right triangles now. So the sides that are attached to the right angle are the legs. The side opposite the right angle is called the hypotenuse. So this is where we kind of get that idea, A, B, and C, that might quickly trigger a bell. That's a squared plus b squared equals c squared, our Pythagorean Theorem. And that's where this kind of comes from, these letters, is through this little naming convention that we use here. So we've got the Pythagorean Theorem, which we know that we can use to find the sides of right triangles. If we have two sides, we can obviously find the third side. Okay, so let's take a look at another triangle. And I'm going to say this is just any right triangle. It may not have a measurement of 31 degrees. It might have various different measurements. And we're just going to look at it in a general sense. So we still have this triangle ABC, with a right angle between A and B, and we've got some unknown angle theta between A and C. So there are three main terms that we use with trigonometry, and that's sine, cosine, and tangent. And you've probably heard somewhere along the lines, maybe if you've ever been introduced to trigonometry before, and there's this phrase called Sohcahtoa. And it sounds like a Native American Indian name, but it's really just kind of a phraseology acronym, if you will, for how to keep track of proportional sides and angles. So what we're going to do is we're going to look at sine of theta. Now we start with this O and this H, and what that means is we're talking about the opposite side and the hypotenuse. So sine of theta is going to be opposite over hypotenuse. So if we look at where theta is, the opposite is going to be B, and C is the hypotenuse. So we would get that sine theta is going to be equal to the same value of b over c. So if we take the sine of that angle, we get the same value that we would get if we divided b by c. Cosine of theta, we've got a and h. Well, we already know that h is hypotenuse. A is the adjacent side. So the adjacent side to theta. So the side that's not the hypotenuse, that is a leg that's connected to theta. So adjacent over hypotenuse, and that's going to be a over c. And then tangent of theta, we've got O and A, which we already know. O is opposite, A is adjacent. So we look at theta and we look at opposite over adjacent. Those are just the legs of the triangle, and that's going to be b over a. So let's say we look at this other measurement now. Instead of theta, let's look at the blue one. That's alpha, lowercase alpha. So let's look at what those would be. So if we take sine of alpha, we still are looking at O and H, so we're still looking at opposite over hypotenuse. But now the opposite of alpha is side A. So we're going to get a fraction of A over C. And as you could probably figure out with cosine of alpha, we are using opposite over hypotenuse again. So now adjacent over hypotenuse. So now we're going to use the adjacent side, which is b over c. And finally, tangent of theta, which you've probably figured out already, is going to be opposite over adjacent, a over b. So something to keep in mind as we go through all of this. This sine, cosine, and tangent can only be used with right triangles. So I've seen people try and use these with non-right triangles. It just does not work. It's about the proportion and the relationships of sides and angles with right triangles. It does not work with other ones. And the other thing to keep in mind is that when we're doing sine, cosine, and tangent, we're referencing angles that are not the right angle. So we never use the 90-degree angle when we use the sine, cosine, and tangent function. So they have to be in a right triangle, and they have to be using the non-right angles. Okay, so that's your basic introduction to right angle triangle trigonometry. And I hope that helps kind of give you a quick summary, and we will talk to you in the next video.